geometry students. Today we are going to learn about circles. We have some vocabulary to talk about to begin with. A circle consists of all points in a plane that are a given distance called the radius from a given point called the center. So in this circle here, point F is the center, and the distance from point F to C is the radius. A segment or a line can intersect a circle in several ways. A segment with endpoints that are at the center of the circle is called a radius. That are at the center and on the circle is called a radius. A segment with endpoints on the circle is a chord. So from A to E is a chord. A chord that passes through the circle's center and made up of collinear radii is a diameter. So from B to D is a diameter. It goes all the way across through the center. For a circle that has a radius R and a diameter D, the following are true. The radius is equal to the diameter divided by 2. The radius is equal to 1/2 times the diameter. The diameter is equal to 2 times the radius. Okay, so there's a few example problems that are already worked out for us here, but we're going to go down and do some of these others together. Name the circle. So how do we name a circle? We use the circle symbol, which is where we draw a circle and put the center point in it so it doesn't look like a 0. And then we use the center point as the name. So this would be circle R. Now we need to name the radii of the circle. So AR is 1, or you could call it RA. It doesn't matter the order of the letters. And then segment RX, RY, and RB. So there's 4 radii drawn on this circle. Notice the plural form of radius is radii. Number 3, name chords of the circle. Okay, so the chords is when you connect 2 points that are on the circle, like A to X and from Y to B. Technically, AB is also a chord, and XY is also a chord. Name the diameters of the circle. So the diameters are the chords that pass through the center. So that's going to be XY and AB. Okay, so now it says, see if I can get this right. If AB is 18, so from A to B is the diameter is 18, find AR. Well, that's going to be half of 18. So AR would equal 9 millimeters. Number 6 says if RY is equal to 10 inches, so that's from here to here, find AR. So RY is 10, then AR would also have to be 10 because the radius is always the same. And AB, well, that's a diameter, so it's going to be double the radius. So that one would be 20 inches. Okay, number 7. Is segment AB congruent to segment XY? Explain. Yes. And the explanation is they are both diameters of the same circle. All right. So, as a quick review, a chord is like from A to E. That's a segment that connects 2 points on a circle. The diameter goes all the way across the circle. Let's see if I can tilt this a little bit. And the center point is the one in the middle that we named the circle by. And the radius starts at the center and goes to any point on the circle. Okay, so those are all very important words that you are going to need to know. Next, we're going to talk about circumference. The circumference of a circle is the distance around the circle. It's like if I took a string and wrapped it around the circle and then pulled it straight and measured how long it is. It's kind of like perimeter, but perimeter is when you add up all the sides, and circles don't really have sides, so we call it circumference. For a circumference of C units and a diameter of D units of a radius R units, C is equal to pi D, or C is equal to 2 pi R. These formulas are pretty much the same because if you do 2 times the radius, you get the diameter. So you can either multiply the diameter times pi to get the circumference, or 2 times the radius times pi to get the circumference. So down here it says, find the diameter and the radius of a circle with the given circumference. Round to the nearest hundredth. Okay, so we're just going to do like 3 of these. We'll do number 1, number 4, and number 5. So we start in each of these with the circumference, okay? So if you take your circumference, we have the formula circumference equals pi times diameter. And so you divide both sides by pi. The circumference over pi will equal the diameter. So we're supposed to find the diameter, and we're also supposed to find the radius. So we'll have to divide it by 2 to get the radius. Okay? Feel free to use a calculator for this. What you're going to do for number 1 is take 40, which is the circumference, and divide it by pi. And if you're using a graphing calculator, you can hit second and then the caret button, which is just under the clear button, to get the pi symbol. And that will actually get you a lot more digits of pi than just 3.14. So this is 12.73, because it says round to the hundredth. So that's 2 numbers after the decimal. And the units would be inches. And then to get the radius, we're going to take this answer that we just got and divide it by 2, because the radius is half of the diameter. So that gives us 6.3. That's going to round up to 7. So the radius is 6.37 inches. Okay? So now I'm going to do number 4. We're going to take 9, which is the circumference, and divide it by pi. 9 divided by pi will give us the diameter. 2.86. So the diameter equals 2.86 centimeters. And now we need the radius, pardon me. So I'm going to take this answer I just got and divide it by 2, because the radius is half the diameter. And that gives me 1.43 centimeters. Okay, number 5. We have the circumference is 79.5, so 79.5 we'll divide by pi, which gives us 25.31. Diameter equals 25.31, and this is yards. And then the radius, we'll just take this answer we got and divide it by 2, and we get 12.7. Oh wait, sorry, 12.65. Forgot what we were rounding to. 12.65 yards for the radius. All right. The next section says find the exact circumference of each circle using the given inscribed or circumscribed polygon. So, an inscribed polygon is one that's inside the circle with the vertices lying on the circle. A circumscribed polygon is one that is outside the circle, but where each side comes into contact with the circumference of the circle. So, for number 7, notice they've given you a right triangle. And on this right triangle, we can find the hypotenuse, which will then be the diameter of the circle. So we can go 8 squared plus 6 squared equals the diameter of the circle squared. And 8 squared plus 6 squared is 100. So 100 is equal to the diameter squared. We'll take the square root on both sides to get rid of the square. Square root of 100 is 10, so the diameter of the circle is 10. So the circumference would be 10 pi. That's the exact answer. So when it says exact, you just leave the pi on it. But another way to write that, if you wanted to do it as a decimal, which I'm also going to accept as an answer, you just do 10 pi and you get 31.42. 31.42 centimeters. So this answer is an approximation because it's rounded off. And this answer, 10 pi, is the exact answer, which is what the directions are telling you to give. But like I said, I'm going to accept that decimal answer also. Okay, so number 8. This one is very similar to the last one. We have a right triangle, and the diameter of the circle is the hypotenuse of that right triangle. So we'll go 9 squared plus 9 squared, notice the tick marks, those are the same, equals the diameter squared. So 81 and 81 is 162, and then we'll take the square root on both sides. And I'm not going to bother with the exact answer this time. I'm going to go square root of 162 and get 12.73 approximately for my diameter. So the circumference is pi times diameter, so it's 12.73 times pi, or we can just go times pi in the calculator, and it gives us 39.985, which would round to 39.99. And the units are inches. Okay. All right. We're going to do 2 more of these, 9 and 10. Why don't you pause your video and try number 9 on your own, and then start it again to see if you got it right. All right, hopefully you've done that. So we have 3 over here also. 3 squared plus 7 squared equals the diameter squared. So that's 9 plus 49 equals 58. Take the square root on both sides to get the diameter by itself. So that's 7.62. So the circumference is pi times 7.62, which is 23.93 millimeters. Hopefully you got that one right. Now let's look at number 10 together. On number 10, they tell you the side length of the square is 11, and they want you to find the circumference of the circle. To find the circumference of the circle, we need either the radius or the diameter. Notice though, if I draw the diameter going straight up and down through the center, that's going to be equal to that 11 yards that we have on the side of the square. So the circumference will be equal to 11 times pi, which you could just leave it as 11 pi for an exact answer, or you can type 11 pi in your calculator and get 34.56. 34.56 yards is the circumference of the circle. All right, next, we have some more vocabulary to talk about. Angles and arcs. A central angle is an angle whose vertex is at the center of a circle and whose sides are radii. So like angle HEG is a central angle. Angle GEF is a central angle. A central angle separates a circle into two parts, a major arc and a minor arc. The arc from G to F is a minor arc, and the arc from G to H to F is a major arc. You have to use 3 letters to name a major arc so that you know you're going the big way around the circle. Basically, a minor arc is less than half a circle, a major arc is more than half the circle, and a semicircle is exactly half the circle. So it says, here are some properties of central angles and arcs. The sum of the measures of the central angles of a circle with no interior points in common is 360. So basically that means all these angles that we add up together in the inside of the circle with the vertices at the center will equal 360. The measure of the minor arc is less than 180 and is equal to the measure of the central angle. The measure of a major arc is 360 minus the measure of the minor arc. The measure of a semicircle is 180. 2 minor arcs are congruent if and only if their corresponding central angles are congruent. And the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs, which is the arc addition postulate. So you can add 2 smaller ones together to get the bigger one that holds them both. All right, so let's use that information to solve some problems down below. It says find the value of x. We have these 3 central angles and we're missing this one. So this is kind of like when you had to find a missing angle in a triangle. You're going to add the ones that you're given. So we got 105 plus 60 plus 115. So those 3 together add up to 280. And now we're going to take the total of 360. Every circle will add up to 360. Subtract 280 from that, and we get 80 degrees left for x. Okay, now take a look at number 2. We have 120 degrees, and this one is a 90. It doesn't say 90, but we know that box means that's 90 degrees. So add those together, you get 210, and then you can go 360 minus 210, and that gives you 150 as x. Okay, now at the bottom here, it says BD and AC are diameters of circle O. Identify each arc as a major arc, a minor arc, or a semicircle of the circle. Then find its measure, okay? Sometimes I find it helpful to go ahead and write the degrees of the central angles before starting. So like that's a 44-degree angle. Since this is an x and these are vertical angles, they have to be congruent, right? So this is a 44-degree angle also. Now, since this makes a straight line from B to D because it's a diameter of the circle, it splits the circle into 180-degree halves. So you can go 180 minus 44 and get 136 for this central angle from A to O to D. And then the one opposite it is also 136 because it's a vertical angle. Okay, so from the arc from B to A, we would call this a minor arc because it's less than half the circle. And the degree measure is 44 degrees. From B to C is still a minor arc because it's less than half the circle, and the degrees for that is 136. The measure of arc CD is 44 degrees. It's a minor arc. It's less than half the circle. Now the measure of arc ACB. Notice I'm going the long way, not the short way from A to B, but A to C to B. You have to use 3 letters. So this is a major arc. It's more than half the circle. It's basically the whole circle minus the 44 degrees. So you can go 360 minus 44 and get 316 is the measure of that major arc, 316 degrees. So that's very big. That's going all the way around this way to get from A to B. Okay, the measure of arc BCD. Okay, that is exactly half the circle because you're going from one end of the diameter to the other end of the diameter. So this is a semicircle, and all semicircles are 180 degrees. Last, we have the measure of arc AD, and that is a minor arc, and its measure is 136. Okay, hopefully you're feeling pretty good about finding arc measures on a circle and classifying them as major, minor, or semicircles. Next, we're going to talk about arc length. An arc is a part of a circle, and its length is part of the circumference of the circle. See where this lowercase cursive L is? We're talking about how long that arc is. Not how many degrees it is, but actually like how long it would be if you stretched it out and measured it with a ruler. The length of the arc L can be found using the following equation. L, which stands for length of the arc, equals x over 360 times 2 pi r. Notice 2 pi r is the circumference. Okay, so you can think of it as the arc length is equal to the degrees of the central angle out of 360, the total of the circle, multiplied times the circumference, which you can do 2 pi r, or you can do pi d, which is also the same thing. It's the other circumference formula using the diameter instead of the radius, okay? So, we're not gonna do all of these, but we'll do number 3, number 4, number 6, and number 7, okay? So, it says for the directions, use circle O to find the length of each arc, round to the nearest hundredth, okay? So it says arc BC if BE equals 24 feet. So notice this is the diameter that they gave us. So we're going to say the arc length is equal to the degrees of the arc. Notice from B to C the degrees is 45 over 360. And then since they gave us BE, oh, that's the diameter, so we'll do times pi d. Pi times 24. So this is what we're going to do in our calculator, okay? So you can get your fraction by hitting alpha y equals number 1, and then 45 over 360, and then you can go times pi times 24, and that gives us 9.42. And this is measured in feet because we are actually measuring how long that segment is. Well, it's not a segment. How long that arc of the circle is. It's the arc length. Okay, the next one says the arc CBA. From C to B to A is actually not needing 3 letters, so that's kind of weird. So this is a minor arc still, even though they've mislabeled it here. The degrees would be, let's see, this is a 90, because that's a 90. So 90 plus 45 is 135. So we do 135 degrees out of 360, And then they give us DO is 3. So then we're going to go times 2 times pi times the radius. So this was the circumference formula pi d, or you can do circumference as 2 pi r. Since they gave us a diameter was equal to 24 here, I used pi d. Since they gave me the radius was equal to 3 millimeters on here from D to O is the radius, I'm using 2 pi r for my circumference. So you can do it either way. And I'll put this in the calculator. Alpha y equals, number 1, 135 over 360 times 2 times pi times 3. So that gives me 7.07 millimeters. All right. The next set of directions says use circle P, which is this one over here, to find the length of each arc, round to the nearest hundredth. So from M to R, we have to find this one. And it gives us P, R is 13 feet. So that's the radius is 13 from P to R. That starts at the center and goes to the outside. Now we need to figure out how many degrees this arc MR is. Notice there's a semicircle from M to T. So that's 180. So if we do 180 minus 50, that gives us 130 for the arc from M to R. So I'm going to go 130 over 360, and then times 2 times pi times the radius of 13. So alpha y equals, number 1, 130 over 360 times 2 times pi times 13. So that's 29.50 is what that would round to, because after the 9 I have 6 there. 29.50 feet. All right, why don't you try number 7 on your own and then play the video back to see if you got it right. All right, from M to S to T is a semicircle, so that's 180 degrees out of 360, and then M to P is 2 inches, that's the radius. So we're going to go times 2 times pi times 2 for the radius. So in the calculator, oops, I pushed the wrong button. Alpha y equals, number 1, 180 over 360 times 2 times pi times 2 again for the radius, 6.28 inches. Okay, hopefully you got that correct. If you have any questions, feel free to let me know. I'd be happy to help you with anything I can. Good luck with your assignment and have a fabulous day. Bye for now.